We are about to begin Unit 6, which is going to be divided into two sections. We're going to have Unit 6A, which is going to cover the Pythagorean Theorem and some special right triangles. And then 6B, which is going to be our trigonometry unit. Okay, don't let that scare you when we get to trig. I promise we're going to break it down really simple for you. But in this first unit, we're going to start with Pythagorean Theorem and then look at some special right triangles when we get later this week. But today, we're going to review the Pythagorean Theorem. Remember, my Pythagorean theorem, a squared plus b squared equals c squared, is the formula we use to find the missing sides of a right triangle. This only works if you have a right triangle. You can't use it in any other. An acute triangle doesn't work. Obtuse triangle, it doesn't work. When you're given your legs that we label a and b, and the hypotenuse is c. When you're filling in your formula, it's very important that your legs, we need to remember, are your a and your b value. And then your C is your hypotenuse, okay? And so that's going to become important because when we label our pictures, we have to make sure that we know which one is our hypotenuse. So when we look at our figure, we know to look at that right angle and then go across from that right angle, and that's always going to find my hypotenuse, which we're going to label as C. That's the important one to get in the correct space because legs are A and B. It doesn't matter if I call the vertical leg here, if I call that one A, or I could call this one down here A. It doesn't really matter where I put my A and my B because we're just going to, after we square them, we're just going to add them together. So if I do the bottom leg squared plus the top leg squared, it doesn't matter if I do that or if I switch it around, this leg squared plus this leg squared. Okay? Now, what we're going to do today is we're going to create ourselves kind of a little shortcut where all you have to do is look at the picture and decide, am I finding a hypotenuse or am I finding a leg? Okay, so here's what we're going to do. When we want to find a hypotenuse, we are going to solve our formula for C. Okay, if I'm looking for the hypotenuse, I'm going to solve for the hypotenuse. My hypotenuse is C. My figure is almost already solved for it. All I have to do is get rid of that little square because I don't want that. Well, hopefully you remember by now that the opposite of squaring something or to unsquare something, we have to square root. If I square root this side, I also have to square root the other side. Okay? Now remember, squares and square roots cancel each other out, but be careful because that only works if there's just one term. Over here on the left-hand side where I have two terms, I can't use this one square root to cancel out both of those squares. Okay, so what I'm going to have to do then is I'm going to have to leave the left-hand side in the square root, and I'll have a squared plus b squared, and that's going to equal, now on this side, since it's just the one term, my square root and my square root did cancel, and all I have left is just c. And c, I know, is my hypotenuse. So from here on out, I know anytime I'm looking for a hypotenuse, which I'm just going to abbreviate HYP, I am going to take my two legs, A and B, I'm going to add them together with a square, and then I'm going to square root that result. Okay? Let's do the same thing over here. What if we're not looking for a hypotenuse? What if we know the hypotenuse, but this time we're looking for a leg? So that means I want to solve for a leg, which I really could solve for either A or for B. It doesn't matter, but we're going to go ahead and solve this for A. Since A is not all by itself, I can't square root because remember you can only square root a single term. And so I need to get this A squared all by itself before I can square root and get the A by itself. So what I'm going to do is I'm going to take this B squared and I'm going to move it to the other side of equals. It's a plus B squared, so to move it to the other side of equals, I'm going to subtract it. Just like I was doing regular algebra, that's going to turn into a 0, right? A plus b squared and a minus b squared is 0. And then I'm ready to bring down my a squared. And that's going to equal, now I'm going to bring these two down, my c squared, and then I'm taking away from that the b squared. So c squared minus b squared. Now I have this a squared all by itself, and I can square root. Okay, so I'm going to do that. I'm going to square root on both sides, because if you do it to one, you have to do it to the other side of the equals. And on the left-hand side, my square root symbol and my square, they cancel out, leaving me with just an A. And on the right-hand side, since I have two terms being subtracted, when the square root can't cancel those squares out. So this side I'm going to leave as the square root of c squared minus b squared. Okay, so A, remember, A is one of my legs. So we're going to now, every time we're looking for a leg, we're going to do the square root of, and we're going to take c, which I know is the hypotenuse, squared, minus b squared. Okay, now here's the important distinction. When I look at my two different formulas here, my hypotenuse equals the square root of something squared plus something squared. My leg equals the square root of something squared minus something squared. So the main difference here is when I'm working with a hypotenuse, when I'm looking for a hypotenuse, inside my square root, we're going to see that we're always going to add. When I'm looking for a leg, I'm going to see that inside my square root, I'm always going to subtract. Okay, and then to know which one has to go first, remember with your A and your B, it doesn't really matter, but over here it is going to matter. When you're looking at your two numbers, you have to make sure the hypotenuse goes first when you're working with a leg. And your hypotenuse, you know, will always be the longest side. So what I do is, no matter if I'm working with the hypotenuse or if I'm working with the leg, I almost always just on instinct, I'll put the biggest number in the calculator first. That way it's always going to work, because I know over here on the hypotenuse it doesn't matter, and over here on the leg the biggest one is going to be the hypotenuse, which has to go first. Okay, so let's look at an example. When I look at this one right here, I have a 5 and a 12 and a C. They've already even told me this is the C because I can see it is across from the right angle, so this is my hypotenuse. So I know inside my square root, to find that C, I'm going to be adding, okay, inside my square root. And it's going to be my two other numbers squared. And I said I always like to put the biggest one in first. When we're adding, that's not really going to make a difference. Don't forget this square there. And then my 5 squared. Now this one, to do these problems, you can do them with a cell phone calculator or a basic calculator, but I would really, really, really recommend taking the time to open up your calculator that comes in your CMS. Remember, you go and search CALC to get that calculator in your CMS, your SchoolNet. When you click on Start Test Now, right up here, you're going to have your TI-84 graphing calculator. And when I click on it, it becomes nice and available to me. I like to slide it all the way over to the left so that I can then minimize that screen around it. And that way I can use it at the same time. And sometimes I'll even minimize this screen also so they are right next to each other and I can work with them back and forth. So I can see I'm going to need to do the square root of 12 squared plus 5 squared. So over here, to get my square root, it's just the little tiny in blue there above the x squared. So I'm going to hit the second, and you can see I hit second because I get my little up arrow, the x squared right here, and then I'm going to type in my 12 squared plus 5 squared. 12 squared right here without the shift, plus, or without the second, plus 5 squared. And you can see, it's kind of hard to tell, but you can see that that square root symbol has stayed above the whole thing, just like it should have. When you hit enter, we're going to see that our C value is 13. And I'll go ahead and put the units. All right, so let's look at one more. Okay, so when I look at this next one, I can see this time I'm looking for a leg, right? Because this is my hypotenuse, so that means I'm looking for a leg, which has already been labeled B for me. Even though we solved for A, it's the same formula. I'm going to do the square root. This time I'm looking for a leg, so inside I'm going to subtract. I know the biggest one has to go first, my hypotenuse. So that's going to be 15 squared. Don't forget to square it every time. And 9 squared. So now I'm going to come back over to my calculator, and I'm going to hit the second key, and the x squared up diagonal from the 7. I'm going to do 15 and then that same square button minus 9 squared. And you can see again, my square root has gone all the way across the top, so all of this is inside the square root. And when I hit enter, I get that the value for b is 12. And again, these are just, we don't know exactly what the units are. Whatever unit the 9 and the 15 are, b is going to be 12 with the same type of units. Okay? All right, in the next video, we're going to continue looking at examples of identifying, are we looking for a hypotenuse, we add, or a leg, we subtract. All right, thank you so much for watching.